So we're going to look now at another C-grade topic, big C-grade topic. It appears in both foundation and higher papers. It hits around the D and C grade work, but it carries a lot of marks, this whole topic in the exam. So it's very worth while spending a lot of time on your revision on it and getting it absolutely right. So it's the topic of this. It's transformations, and we're going to look at both when you need to perform a transformation and also identify a transformation. So let's have a look at some of these then. The first one we're going to look at, we're seeing this table here, is our transformations and the details we need for it. Being asked to translate triangle A using the vector 3, 1. So we can translate a shape. When we translate a shape, we're given the vector. The top number in the vector tells us how much we need to go to the right. And the bottom number in the vector tells us how much we need to go up. So what I'm going to do, I'm going to translate this triangle here through the vector 3, 1. I'm going to pick a corner. I might pick that corner there. It now needs to go across 3, 1, 2, 3, and up 1. So that corner will now end up there. And as will all the other corners as well. 1, 2, 3, 1. So that corner's there. 1, 2, 3, 1. So that corner's there. So the triangle now will end up there. So it's gone across 3 and up 1. Okay? Let's have a look at the other one. It says translate A using the vector 4, minus 2. So again, I might pick this corner here. I've got to go across 4, 1, 2, 3, 4, and this time down 2, because it's a minus 2, so 1, 2. So that corner will now end up there. Same with the other corners. 1, 2, 3, 4, and down 2, 1, 2, so that corner will end up there. And the top corner, 1, 2, 3, 4, 1, 2. So it will end up there, and the triangle will have stayed the same shape, but it's moved across 4 and down 2. So translation there. Moving on, this time I need to answer this question. Describe fully the single transformation that maps A onto B. Well, I can see it's not been twisted, it's not been reflected, not been rotated. They're the same size as well. So I think that is going to be a translation. So for 1 mark, I would say translation. But then, if I look at my table, whenever I give a transformation, I've got to give the details about it as well. So I need to give the vector here. So I need to write the vector as one number on top of the other, not as a coordinate. And I'm going from maps A onto B, so there to there. So if I pick a corner, this corner has gone back 3. So if it's gone back 3, the top number needs to, if it's gone to the left 3, it needs to be a negative 3. And then it's gone up 1. So that's still a 1 there. So it's gone minus 3 and then 1. So remember, the top number tells you how much you've gone to the right. So if you need it to go left, it needs to be a negative. The bottom number tells you how much you've gone up. So if you need it to be going down, then it needs to be a negative. So back 3 and up 1. So it's minus 3 and up 1. So that's translation. Next one. Let's have a look at this. It says here, rotate A 90 degrees clockwise about 2, 1. Okay, so the first job I'm going to do is I'm going to plot that centre of rotation. So with the rotation here, I need the angle. Well, I've got that. I need the direction, which tells me I'm going clockwise, and I need the centre of rotation. The centre of rotation is 2, 1. So 2, 1. That point would be there. And what I'm going to do at this point, I'm going to freeze the board. Hopefully. So then what I would do, I take a piece of tracing paper. So here's my tracing paper. I would put the tracing paper on, not at an angle, but I'm going to put it square onto the page, like that. And now I'm going to carefully draw around my shape, like so. And then I'm going to put my pen in and stick it in at the point where the centre of rotation is. And now it says to rotate A 90 degrees clockwise about 2, 1. So it's about that point there. I'm going to rotate the paper 90 degrees clockwise. So my shape will end up there. And now I need to sort of lift up my tracing paper and draw it on there. But I'm rotating the paper rather than thinking about the shape rotating. I'll draw that on there. So that's always ask for tracing paper if you need it in the exam. Okay? Still with rotation, this one says, it's asking me to rotate it, I haven't gone back to the next page yet, there we go. This one says, describe fully the single transformation that maps A onto B. Well, it looks like it's been rotated to me, so that would be for 1 mark. I would put rotation, it's for 1 mark, but again I need to now give the angle. So the angle, well, it looks like the sort of sharp corner was facing that way before, it's now facing down. So I think it's been rotated 90 degrees, rotation 90 degrees. We're going from A to B. Now that is anti-clockwise, that's the opposite of the way the hands go around on the clock. So it's anti-clockwise, rotation 90 degrees, anti-clockwise. And then I'm going to put about, and I need to give the coordinates for the centre of rotation. So I'm just going to freeze it again. Now 9 times out of 10 they use a fairly obvious place for these rotations, but what I'm going to do is I'm going to put my tracing paper on here again square on, not at an angle. I'm going to draw around my shape like so. I'm going to see if I can work out where that centre of rotation is. So is it there? No. Is it there? Whoops. Yes, it is. Fantastic. So it's at that point there. So I had to do a bit of investigating around there, but I've realised that it's at that point there. Okay, so that is the point 0, 1. Okay, excuse the fact that everything's moved around a little bit here. Okay, so it's about 0, 1. There we go. Okay, right, let's have a look at another one then. Now, so we're talking about reflection now. Reflection. And with reflection, we need to have a mirror line. So the first one says to me, reflect A in the x-axis. Now, this is the x-axis here, the horizontal one, and this is the y-axis. So reflect A in the x-axis. So I need to imagine there's a mirror there, and that would be flipping over here. Well, I can see that this line is 1 square away from the mirror line here. So it also needs to be 1 square away this side as well. So there we go. That's A, now reflected in the x-axis. Okay. Next question says reflect A in the line x equals 1. Now I've got to be really careful about this, finding out where x equals 1 is. X equals 1 is actually that line there, where all of the x values for the coordinates would be 1. So that would be x equals 1, x equals 2, x equals 3 and so on. So excuse my little marks on my board. Okay. If I had horizontal lines, there would be y equals 4, y equals 2 and so on. But this is x equals 1, so I'm going to reflect in that line. It's 1 square away there, so it needs to be 1 square away here. So I think we are looking like that. Okay, so again, don't make the mistake of reflect it in the y-axis, but we've been asked to reflect it in that line there. 1 square away, 1 square away, and then I think we're done. Okay, so reflection there. This time, I've been asked to describe fully the single transformation that maps A onto B. Well, I could probably make the mistake here of thinking it's being rotated, but actually, if it was rotated, I think that corner would be on that side. So I think it's actually been flipped. I think it's been reflected there. So my first job is to draw on the mirror line. And if I'm very careful, I think the mirror line is there. Okay? So describe fully a single transformation that maps A onto B. I would say reflection for 1 mark. And then I've got to give this line here. Now that equation of that line is actually y equals x. So I would put there reflection in y equals x, and that's going to give me all the marks for that. So when you give a reflection, you have to say what the mirror line is as well. Okay, let's have a look at another one. So this time we're on to enlargement, the last one, and with enlargement we need a scale factor and we need the centre of enlargement. So I'm being asked here to enlarge A by the scale factor 3. That means every line is going to get 3 times bigger. Centre of enlargement's got to be 2, 0. Well, let's mark that first, that's centre of enlargement, that's 2, 0 there.